Today we're going to learn about using the triangle congruence postulates. So in the previous video we looked at what are the 5 triangle congruence postulates. And then here we're going to actually use them and determine if two triangles are congruent. So the instructions on this one say determine if the two triangles given are congruent. If so, state the appropriate triangle congruence postulate. Also, give an appropriate congruence statement. So I have two triangles here. I have ABC and I have DEF. And the question is, are these two triangles congruent? And so what do we know? We know that there's a 5 centimeter on the ABC and there's a 5 centimeter line on the DEF. There's a 140 degree angle over here, there's a 140 degree angle over here. And there's a 4 centimeter line here and a 4 centimeter line here. So we have two sides as an angle in between them, and they match up with these two sides and the angle in between them. Now, of course, the 5 is out on top here and the 4 is on bottom, where here the 5 is on bottom and the 4 is on top. But that's okay. We have the two sides with the 104 in between and the two sides with the 104 in between. So these triangles are congruent. And the question is, well, why are they congruent? So yes, they're congruent. Yes, congruent. And they're congruent because of the side angle side postulate. So side angle side. We've got the 5, the 104, and the 4. Okay? So then it says give an appropriate congruence statement. So this is where we would say triangle ABC is congruent to, and then we have to get the letters in the correct order over here. So ABC went across the 5 centimeter line to the 104 angle, and then across the 4 centimeter line, if we kind of go across the path ABC. So we want to go the 5 centimeter line to the angle, and then across the 4 centimeter line, so it would be DFE. So triangle DFE. Okay, so that's our first example. We got a few more to go through. Here is an example. It looks kind of like a bow tie, and so they gave you that this is 13 and this is 13. This the ML is 12 and KL is 12. And we want to know, are these two triangles congruent? So one other thing that they don't tell you but is true is that this angle is the same as this angle, because these two angles are vertical angles, and so they're always congruent. And so now by looking at this, we can tell that this has a side, the middle angle, and the side. Same thing over here, the side, the middle angle, and the side, and the numbers match up. So this would also be a yes because of side angle side. So I haven't gotten too creative here. There have been two yeses with side angle sides. So what order should we write them in? So if we had MLN, triangle MLN, so that was congruent to, and then what triangle over here? So MLN went across the 12-inch line and then the 13-inch line. So it'd be KLJ would be the correct order. Okay, let's look at the next one. So here we have a triangle that's been cut right down the middle. And so this is 26, this is 26. So what I'm thinking is I see two triangles here. Actually I see 3, but I'm looking at 2 smaller triangles. So let's change this color to red maybe. And so I see one triangle that goes right here. And then we'll go blue. The other triangle is right here. Okay, and my question to you is, are the red triangle and blue triangles congruent? And so we know that we have one side length that match up. We know they both have 90-degree angles. So if we have one side and one angle, that's not enough information. But if you notice this QO line here, that's the same on both of them because they're back to back. So we can say that this line is also congruent. So we have a side, another side, and an angle. And we have a side, another side, and an angle. And if you recall from last video, I said that side-side angle does not work. That one I called the donkey theorem. And so this one I'm thinking would be a no. However, it is a right triangle. And so it's a right triangle. We know the hypotenuse, and we know one of the legs. And here we know the hypotenuse and one of the legs. So this actually would be a yes. These are congruent here. So this would be yes, and it'd be hypotenuse leg. Okay, and then we can draw a triangle congruence statement. And so I've just been randomly picking. I've been doing like RQO. So we'll say triangle RQO. If you decide, like if you randomly chose ROQ, that's okay. Your just letters would be in a different order than what mine will be for the blue triangle. So if I said RQO, that would then what matches up would be PQO on the other triangle. So RQO is congruent to triangle PQO. Okay. All right, I think we have one left here, if I remember right. Yep, one left. And so here we have a triangle over here with some stuff and a triangle over here with some stuff. So we've got a 55 and a 55. That's good. We have an 80 and an 80. And then we have a 24 and a 24. So it looks like I have two angles that match up and a side that matches up. And the side is not in between the angles in this case. So this looks like it would be angle, angle, side instead of angle, side, angle. So it would be angle, angle, side on this one. So this would also be a yes. And this one we said is angle, angle, side. Okay, now let's draw or write a congruence statement. So I'm going to say UTS, triangle UTS, is congruent to, and then we need to get the order right over here. So U is the 55, T is the 80, and then S is the one that we don't have a number on. So that would be WVX. So angle WVX. All right. Hopefully this helped you understand using triangle congruence a little bit better. On to the next video, which is triangle congruence proofs.